All right, Yannick. Start with introducing yourself and how long you've been in, the beautiful space of interoperability.
Yeah, my name is Yanick Gaudet. I am based in Ottawa, Ontario, Canada. I've been doing healthcare IT for over 30 years now. Started my career as a EHR implementer, and I've implemented an EHR called Oasis back in the 90s across the United States, Canada, and even internationally. Um, with that, I transitioned to becoming the actual chief architect of the EHR. And all of that always working with obviously the data model, so clinical data modeling and a lot of interoperability. Being an EHR, you need to be able to get data in and get data out. So I became an interrupt specialist. Played with HL7 since the mid 90s, HL7 V2. And then obviously when FHIR came up, jumped onto to FHIR to a point where I'm even now a co-chair of the Order and Observation Working Group at HL7.
That's amazing. So we are, of course, doing this interoperability masterclass for those who have interests in interoperability, who are working with medical devices. However, for folks who may be experiencing this topic for the first time, just in a very short, succinct way, just explain what is interoperability for those who are joining us for the first time.
Of course. Well, interoperability is not something that is healthcare specific, right? Interoperability as a definition is from an IT point of view, it's for two systems to communicate or exchange data. In a lot of ways, banking been doing interop for a long, long time. The thing with the banking industry, for example, if they have a very hard standard and all banks exchange the same kind of information, and there's a fairly limited amount of information exchange in banking, for example. At a position to healthcare, where there's a very large amount of data being exchanged, different type of data, different type of system involved in healthcare data exchange. If we're talking about imaging from a radiologist system to a lab system or dietary system, admission system, or the EHR, which kind of grabs all of this information to give a simple view of all that data to the healthcare professional. So interoperability in healthcare is a lot more broad and a lot more complicated. We've been doing it for way over 30 years, and it's still complicated and difficult and time consuming and expensive to do good interop. So interoperability is the exchange of data between systems. In healthcare, it's the exchange of healthcare data between systems.
Thank you. So before we zoom in, let's zoom out first, right? I think the industry has been talking about creating a connected digital healthcare system for a while now. In your opinion, then, why do you think interoperability feels more urgent than ever in today's environment?
Yeah, and
Yeah.
actually,
Yeah.
I'll take a zoom out before zooming in into that specific question, right? When I started my interrupt journey, um, it was really mostly 5 to 10 systems, sometimes 15 systems in really large institution that wanted to talk within the institution. There was no data coming in and out of the hospital or the healthcare facility. It was all the system physically connected to the same network inside that hospital that needed to communicate, right? Different vendors, different operating system, and back in those days from mainframe to PC to Unix servers, but all physically meshed or connected within the same server room. If we look back 30 years later, my watch actually collects, my heart rate, my body temperature. My phone knows how many steps I did. That's consumer data that could be valuable to a cardiologist. The amount of data, of healthcare data that is generated today is a lot larger than it was 20 years ago, 30 years ago, and I would even say 10 years ago. So Interop kind of blew up in a way because there's a lot more data being generated. There's a lot more system being involved, and the system are no longer all confined within the same physical area, right? It's all over the place. It's cloud-based, it's server-based, it's consumer-based, it's healthcare provider-based. You can have a physician in his home office that needs to have data from the healthcare facility, right? And exchange data that way. So when we zoom in into today's world, you can be a device manufacturer that builds a consumer device like a scale to weigh a person. Well, that scale actually kind of generates healthcare data. What's the body weight of my patient? In some cases, you want a patient to gain weight over time. If that scale that generates the weight of the patient can actually send that data to the healthcare professional or to the physician, that's valuable for that physician. So that's why Interop has blown up in the last 2 or 3 or maybe 5 years in terms of more people are a lot more interested into it. And with the AI avenue coming in, AI with a generalist LLM is great, right? It can do great things. But if you provide your AI better data, more precise data about a patient, about a case or a population, that AI will be smarter because it gets better data. That also means it needs to get good data, right? And good interoperability and good data governance will give you good data, which gives you better AI. So Interop is at the center of all of this. You can have tons of system and devices that generates data, but if the data is not consumed or exchanged properly with good governance, that data is kind of useless.
Yeah. So you're saying before interoperability, there is that step to make sure your data in itself, the quality is good. There's integrity in the data, there's quality in the data, or else the process that you take on in terms of interoperability would not do its function if the data is not high quality. Is that
Yeah,
right?
no, absolutely. Interoperability is it's a statement I say all the time. Like it's about 80% politics and 20% technical work. The 80% of non-technical work is data governance and good data modeling and terminology and ontology, making sure that your data is captured and possibly as much as possible codified appropriately. Free text in the healthcare is not necessarily a good thing because a physician could textually document in his system BP, 120/60, or blood pressure column 120/80. Well, those two strings individually, they're hard to mesh. They're hard to say, yeah, it is to blood pressure. But if you model your data properly and if you structure your data properly, the data you'll exchange will be a lot better because you know exactly what you're talking about. Um, that's not a technical problem. That's more, and it's not functional, but it's a governance problem. It's a modeling problem, right? So, and it's a problem that's been solved, and we solve it. Um, all the interoperability expert push that envelope a lot, right? That the interrupt part is exchanging the data, but in order to exchange good data, you have to have good governance in
Mhm.
and out of that data. How do you prepare the data to be sent, and how do you prepare to receive that data and consume it properly?
Yeah, exactly. Technology is the enabler, not the magical pill to solve everything. With that, I think that's a good segue then, Yannick. Tell us the difference between HL27 V2 and FHIR, and really why FHIR has been such a fundamental change to interoperability.
Absolutely. Um, V2 is I don't want to say ancient, but it's old. Pre-90s, right? I think it started in the 80s, really well adopted in the 90s, and still used around the world a lot. It is the number one protocol used to exchange clinical data right now. Non-imaging data, DICOM is his own little world for imaging, but for lab and reports and observation and most of the other kind of information, HL7v2 is the number one protocol still used. With that being said, it's a very old protocol. With that, it's very stable, right? Everybody knows it, everybody can use it, and it does its job really, really, really well. But we're, 35, 40 years later, there's new technology and there's new things that is better. One of the bad thing, or not the best thing that V2 had, is strict rules about what you put where and how you structure your transaction. In all intent purposes, you can almost put anything anywhere and nobody's gonna complain about it as long as the receiver knows what you've put in that specific field. Everything's fine. FHIR is a lot stricter about that. The structure of our data in FHIR is a lot more defined and explanatory, right? When I say the name family, in a patient.name.family, well, it's obvious it's the family name that goes in there. And we have better codification and better way to structure the data, but also constrain our data. So FHIR is stricter, which makes the exchange of data better. And it also makes it somewhat easier to exchange data between systems because our protocol or our standard is stricter. The other thing that FHIR brought to the table, which is super important, I think, is we have the core spec, right? So we have the FHIR core spec, which is the definition of all the element that the community has defined as usable or that can be defined and exchanged between systems. But we can then profile those resources in FHIR, which allows us to say, in this specific context, when you send an observation, here are the fields that should be exchanged, and here are the constraints on those fields. So when we take, for example, in the order and observation world, we have the vital signs profile. So we've profiled what the community believe the vital signs should be. So when we exchange a body temperature or blood pressure, it's been already profiled to a very small subset of what the data should be with the right code, with the right type of value, so that you can't send a blood pressure any way you want. You send the blood pressure that way. So if you send it the profiled way, that means the sender and the receiver, they know exactly what you're talking about. I know exactly, with no extra work, with no interoperability expert like me being involved, the blood pressure will be exchanged and consumed properly, the vital sign and lab results, right? So profiling a FHIR spec allows us to have very specific rules and constraint around what we exchange, which makes the exchange easier and faster. And that actually reduce the cost of interoperability.
Question on that, actually. So, of course, this API-driven methodology is really critical, clearly also very beneficial. But then if we flip it, why aren't all the medical device companies and manufacturer, pharma, different players in the healthcare industry not fully adopting FHIR with all the benefits you've outlined? Are there barriers in terms of adoption, or is it just that 80% politics? What are some of the factors I think the industry needs to take into consideration to really move towards this connected ecosystem?
Yeah, there's a lot of factors, right? We can talk about some of them. One of the factors is if you're a really large device manufacturer of the world and you're in 80 different sector of healthcare, and you've been creating devices and systems for 25 years, and they're all HL7v2 compliant, and they're installed in hospital, and everything is working fine and it's working well. changing that is very costly. It's very costly for the manufacturer that now has to upgrade and update their system, right? It's very costly for the hospital to actually migrate this, which means now their integration engine may have to speak FHIR. And is the receiver of that transaction will be FHIR enabled also, or will I now have to do a FHIR to V2 transformation in my integration engine? So there's a lot of component that says switching to FHIR, while it's beneficial, while it's great, and I say to our clients, yeah, you should think FHIR first. There's still a massive cost to this. If you're a startup, if you're starting to build devices or software, I would say think FHIR first. Build with FHIR in mind, right? So that when the future comes really into play and when FHIR is really adopted everywhere, you're ready for it. And FHIR and V2 are somewhat exchangeable. We have a project called V2 to FHIR, which has mapping of this field is here in V2, that's where it goes in FHIR. So there's ways to actually transform your data from one format to the other, or one standard to the other. So why is FHIR not widely adopted overnight? It's mostly a cost. It's very time consuming and very costly to do such transition.
But it is necessary, and it's only a matter of time for everyone to be, like you said, FHIR native. So either you start with FHIR, or you're going through the transition from going V2 to FHIR.
Correct.
Of course, I cannot talk to you without mentioning AI, obviously. How do you see, like, what do you think AI's role is in terms of in the field of interoperability, especially around generative AI and agentic AI, which is very much a hype amongst all the enterprise at the moment?
Yep. So there's two part of that, and I'll be very honest with you. There's part of my job where when I need to do a very large amount of simple mapping, which I used to do manually, right? Like Excel spreadsheet, like this field goes here, that field goes there, this field goes here. So from an interop engineering point of view, AI can really help there. Most AI, and I won't name any by name, but most AI do understand HL72 and FHIR really well. So you can say, okay, I need this kind of transaction to be moved here. I need this to be mapped into that database, and here's a field name, blah, blah. So AI from that point of view is really good. The other part of AI, and that's technical, that's to help guys like me, to guys and girls like me to build interoperability. The flip part of that is I think more where the healthcare industry is going, is to use AI to make better, faster decision, right? If you take a chronic disease patient that's been diagnosed 10 years ago, that has blood work done every 3 months, that's a lot of results. And that's a lot of results for a healthcare professional to sift through to find a pattern. Why is my patient every 18 months has a flare up, right? What is the socioeconomic problem? What triggers that flare up every 18 months? Because the lab result doesn't show anything, right? If you feed all that good data into an AI, it's going to take maybe not seconds, but minutes for AI to actually find a pattern. AIs are amazing at finding patterns. So that's the magic bad word. That's a beautiful part of what AI can do, is sift through an amazing amount of data and find patterns to either prevent a flare up or find out why there is a flare up. And that's one example, right? But like I said earlier, garbage in, garbage out. If your data is not good, if the data you feed to your AI is not proper data or good data, or the data cannot have good correlation, because now I have lab result come in from this private lab and lab result come in from this hospital lab or public lab, and it's the same CBC or complete blood count, but they don't use the same WBC code, right? One is with diff, one is without. How can I make those results proper? How can my LLM or my AI use those results or all those data points to have good analysis. And that's where I was saying earlier, if you have good governance and if you have good interoperability, you'll have good data. If you have good data, you'll have better AI, right? So interop doesn't solve anything in here. It just helps. It just helps to get our AI to be, I don't want to say smarter, but more precise, right? And to make sure that the AI won't hallucinate or won't find a pattern that doesn't exist because part of the data set it received wasn't accurate.
Mm-hmm. And it clearly has a direct impact to the patient experience, the quality of care, because all this, the entire care experience, if it's interoperable and the data is flowing and the quality of the governance, and also AI doing, it's accelerating the right part of this care experience, clearly is impacting or benefiting the overall care experience. Yeah, before I let you go,
I want to add something else on top of that. That's
please.
very one of the things that's been not in the news but recently brought up a lot, right? Clinical trial times, right?
Mm.
It takes forever to run clinical trials on new medication, new drugs, new therapeutic procedures. Um, there's multiple factor into that, right? Like rate at which a patient drop off the trial, right? When you do a clinical trial, you need a certain amount of patient, and if you lose too many patients, the trial has to stop. They have to restart the trial. But clinical trial is also about analysis of a lot of data, right? They want to make sure that the side effects aren't too bad, that the side effects are really related to the clinical trial, not something else. That's a lot of data for a lot of patients, often in a large geo area, right? It's not, in one state or one province or one jurisdiction. It's, I don't want to say globally, but it's wide area, wide patient pool, lots of data that need to be analyzed. So from a clinical trial point of view, it can also improve the speed at which a trial can be completed, which also at the end helps our patient, right? But it's another aspect. Like we talk about, a lot of people are talking about agentic AI or AI to help the healthcare practitioner or the physician to make decision, right? In some cases, we saw that some AI can detect better than a radiologist a tumor or a growth that over the last 3 MRI has been growing. Well, if it grows by a tiny little bit, the radiologist may not be able to pick it up, but the AI can. So again, the outcome for the patient is good, but it's not only the first line practitioner that can use AI to do their job better to, at the end of the day, still improve the life of the patient.
Um, we'll definitely come back to this topic in our future masterclass. Yanick, what are some of the concrete recommendations then you have for, medical device OEMs, pharma that they can do this year? Because clearly there's a lot of noise, not only in the industry, but also in tech overall. What are some very practical, concrete things you would recommend them taking as actions?
So I think for even well-established corporation that already have interrupt systems in place or interrupt devices in place, is to make sure that your interrupt strategy is sound. You may have never done an interrupt strategy. You may have never looked at where you are today and how you got there. Without judging why you got here, sometimes it's good to open up and say, this is where we are. And it may not be the good place anymore, right? It was the right place to be from an interrupt point of view 10 years ago, but in 2026, is it still the right place to be? And with that, it's like, what's my strategy? What's my vision from an interrupt point of view, right? Considering where we are today, considering the global market, considering AI taking a lot more room in healthcare, is to have a good a good vision and strategy and roadmap to say, this is where we are today and we're okay with it, or this is where we are today and we're not okay with this. And how do we go from we're in an okay place from an interrupt point of view to we should go into a great place from an interrupt point of view, so that when you do come to a client, when you do a sales pitch, that when you get asked the interrupt question, you're not wondering what's the right answer, that you know where you should be going from an interrupt point of view. So I think one of the first thing that I say to most clients, new and old, is what's your strategy for an interrupt point of view? Which, interrupt as a big statement mean, what's your data modeling strategy? What's your data governance strategy? With and without interrupt, right? Because data governance and data modeling needs to exist with and without interoperability, but it's still at the heart of having a good interrupt.
Mm. Strategy. And I will even say interoperability, the interop strategy probably ties into the overarching business strategy as well,
Mhm.
because data clearly is a critical component to all the, digital devices and also the exchange of like patient
Yeah,
experience.
yeah.
All right. Okay, good.
I'm gonna add on top of that. Too often, um, interrupt is an afterthought, right? People are specialists into their own little world, and that's fantastic, and that's what needs to happen, right? If you're a specialist in, a device that measures steps, that's your specialty. That's fantastic. And you build a device, you build a system, you build everything to, check the distance that you've walked and stuff like that. Awesome. And then you figure out later that you need to send that data to external system. Um, and the way I see it, it's an afterthought. And that becomes very complicated and usually very costly. So even if especially if you're a startup, and you're building some kind of medical device, any kind of medical device, think about interrupt right away. You don't have to act on it. You don't have to make your product interoperable, but think about it right away so that your foundation
Mhm.
uh, has that built in, right? So that when it's time to become interoperable, you don't have to go back to your data model and to your infrastructure and to your architectural design and rebuild everything or bolt something weird on top of it and start to to use duct tape to build a Frankenstein kind of system, right? Think about interrupt right away so that when it's time to become interoperable, your foundation's already there.
Perfect. Yeah, Nick, thank you.